Hello, I'm Channing Benson, an experimentation advisor here at Split Software, to talk to you about a feature of Split's experimentation platform, multiple comparison correction, or MCC. In this video, I'll cover what MCC is, how to control whether MCC is enabled for your Split org, and then I'll give a demonstration of how MCC affects whether a given metric impact is considered to be statistically significant. First, some background about p-values and how they are calculated for a metric when MCC is not enabled. Every time Split calculates the impact of a metric, the percentage delta in a metric value for a given treatment compared to another treatment as a baseline, it uses a calculation called a t-test to determine a p-value. The p-value is the probability that one would see an impact as great or greater than the calculated impact completely due to chance. In other words, if the treatment has no actual effect on the metric in question, what's the chance of a swing at least as large as what was measured just due to some random fluctuations in the data? Let's say the calculated impact of a treatment over the baseline on a particular metric is a 10% lift, but the true impact is negligible. There is no real difference in the metric between the two treatments. Then there is a 5% chance that the p-value will be 0.05 or smaller, a 10% chance that the p-value will be 0.10 or smaller, and so forth. Since each p-value is calculated for a metric in isolation, the more metrics you have, the higher the probability that at least one of those metrics will show a false positive. With a default significance threshold of 5%, 1 in 20, if you have 20 metrics and there is no true impact of the treatment on any of them, it is highly likely that at least one of those metrics will show a false positive. What you really want is a way to control the overall false discovery rate. That is, the chance that any of the metric comparisons showing a statistically significant result are false positives. Fortunately, Split has a feature, multiple comparison correction, or MCC, that does just that. By taking into account how many metrics are being tested and adjusting the p-value from each metric calculation accordingly, MCC controls for the overall false discovery rate, the fraction of all significant results which are likely to be false positives. If you have multiple comparison correction turned on in the monitor and experiment settings of your Split org, then the displayed p-values of your metrics will be adjusted via a Benjamini-Hochberg correction that accounts for the overall number of metrics. For a given split, the correction is done for two separate groups of metrics, the key metrics for a split and the remaining or organizational metrics. So what can change in the split interface when MCC is enabled or disabled? So one of the things that might happen is a metric that was, when you turn on multiple comparison correction, a metric that was previously statistically significant due to chance might become inconclusive. The displayed p-value for a metric impact is changed, typically is increased by the application of multiple comparison correction. Error margins change, and then on the metric details page, there is a piece of text that tells you for that particular metric comparison whether or not MCC was applied. So now let's look at multiple comparison correction in action. The way you access the setting of multiple comparison correction, whether it's enabled or disabled, is in the admin settings of your Split org under Monitor Window and Statistics. And at the bottom, there's a section Multiple Comparison Correction. And right now, it is not enabled. So let's go look at some metrics and see what we see. So this split is an AA test, which means there is no difference between the two treatments. In other words, the null hypothesis is true here. So any statistically significant metrics we see are false positives. And you can see in this case, we've got a number of metrics, around 20 or so metrics. And so you would expect, because of the way that p-values work, that one of these might happen to be a false positive. And you can in fact see that this metric, sum of order values per user, is showing a statistically significant impact in the desired direction. The card is green. Keep in mind that the impacts and the p-values for all of these metrics are calculated in isolation. Each metric is each p-value is calculated only looking at the data for that particular metric. Now let's see what happens when we go and turn multiple comparison correction on. So we go back to our admin settings here. We click on, we check the box, apply correction to your metrics. We save, come back to the metrics impact tab, and we refresh. So the correction gets applied immediately, but you have to refresh your browser. And now notice on this same split, we have 0 metrics with significant desired impact. And this sum of order values per user, which previously was statistically significant, is now inconclusive. And we can see the p-value, the corrected p-value is 0.34, and that's greater than our threshold of 0.05. So we say this is not a significant metric. The impact was not due to the difference in the treatments. Now keep in mind what I said before about the fact that we're applying the multiple comparison correction over 2 groups of metrics. The key metrics, in this case right now, we don't have any key metrics set for this split, and the organizational metrics. So if I take this metric and add it as a key metric, and I only have a single key metric, it's going to have the same p-value that we had before, 0.04. It's less than 0.05, so we're going to consider it to be statistically significant because we're only looking at this one metric. Now, what do you think might happen if I added another metric as a key metric and we were applying the multiple comparison correction across both metrics? Let's try that and see what happens. So I'm going to just pick one of these statistically insignificant metrics, add it as a key metric, and now the adjusted p-value of this sum of order values per user, the p-value has gone up because we're applying the comparison correction across 2 metrics, and it is now statistically inconclusive. So the lesson here is that, due to the way frequentist statistical approaches work, there is some possibility that the null hypothesis would be true and a metric would be statistically significant. That possibility increases the more metrics you have. And so in order to reduce that possibility and give you more confidence in your results, we have this new feature, multiple comparison correction. Whether or not it's enabled for your particular split organization depends on when you became a split customer. So if you're wondering, the easiest way, the one way to do would be just click on any metric, look at the metric details page, and you can see there's this little section right here, multiple comparison correction applied, and then it gives us a little, little blurb on how that works. Or you can always just go to the admin settings and see if it's clicked here or not. So I hope that was helpful and helped explain how Split is giving you more confidence in your experimental results. I'm Channing Benson, Split Experimentation Advisor.